little part has to deal with, well, what happens if I run into not one absolute value in my equation, but two? So what if I have an absolute value on both sides? And what this equation up top says that if you've got an absolute value on, on both sides of your equation, notice what happens is the left-hand side, whatever's inside of the root, stays the same just like before. So the left-hand side, whatever's inside the root, stays the same. And you're still going to do what you did before. Whatever's inside of the absolute value on the right-hand side, we're going to do the positive version and a negative version of what's inside on the right. So you'll have, again, two equations that you're going to set up. And just like before, what's inside the absolute value on the left will stay the same. And on the right-hand side, you're going to do the same thing you did before, which is take whatever's inside that absolute value and do your positive version first and your negative version second. So nothing has really changed. You're always going to do your positive version and your negative version. So let's take a look and see what that's going to actually mean for us. So let's take a look at this first example. We've already got our two absolute values, one on each side, so we can just go ahead to jump to making our two equations. So let's take a look. The first equation and the second equation will start off the same. Whatever's inside the left-hand side, inside the absolute value, will stay the same no matter what. That'll be the same throughout this entire section. So the 5x minus 7 should stay the same. The next part is taking whatever's inside of the second absolute value and doing the positive version and a negative version. Well, in the positive version, that's a fancy way of saying just leave it the same. So it's a 4x plus 1. It needs to stay as a 4x plus 1. So in the positive version, it stays the same. However, in the negative version, it means to switch all the signs. So if we had a 4x that is positive, it will become a negative 4x, and the 1 is positive, so that will become a minus 1. And we still have two equations to solve. It shouldn't be too big of a deal, so let's start with the one on the left. We'll get the x's on the same side by subtracting 4x from both sides. So what that now gets me is x minus 7 equals 1. Then we can add 7 to both sides. And let's see what that gets me. That gets me that x equals 8. Okay, let's solve the other equation. It's going to be slightly different. We're going to start by adding 4x to both sides, which will give us 9x minus 7 equals, be careful, that's a negative 1 on the other side. And then we will add our 7 to both sides of the equation to get the x term by itself. And that gets us, let's see, 9x equals negative 1 plus 7 is a 6. Now dividing both sides by a 9. That'll get rid of my 9 and leave me with x equals 6/9. The problem with this is it's a fraction and it can be reduced. Both are divisible by 3, so that will reduce to 2/3. Now you can double check these by plugging them back in. It's up to you how much time you want to take, but you do get two answers, 8 and 2/3. And we're done. So remember, you're still doing two versions. You're doing a positive version where everything stays the same. And the negative version, the right-hand side, you switch all the signs. Let's take a look at another example. Remember with these, when you've got two absolute values, one on each side, when we take a look at B, remember that the left-hand side, whatever's inside its absolute value, always stays the same. So we'll start out with our two versions, our positive version and our negative version. So our positive version is going to start out by leaving the left-hand side the same, the x minus 1/4. And our negative version is going to start out the same too. The left-hand side, whatever's inside of the root, will still stay the same, x minus 1/4. It's the right-hand side that may change. Okay, so now we're going to look at the right-hand side and what's inside its absolute value to figure out what's going to go on the right-hand side to each version. Remember, on the first one, we're looking at the positive version, so it should stay the same. So if it was an x minus 4, it's going to stay as an x minus 4. That's what it means to look at your positive version. The next one, we're actually going to do it where the signs are switched because we're looking at the negative version. Well, what does it mean to switch the signs on x minus 4? Well, the x was positive. It's going to become a negative. The negative 4 will become a positive 4. So the positive x became a negative x, and the negative 4 became a positive 4. So we switched all of the signs to do the negative version. Okay, so continuing along, we need to solve both of these equations and see what happens. So the first thing I would do on the first equation is try to get the x's on the same side by subtracting x on both sides. What you do notice is that the x's cancel on the left and the x's cancel on the right. And it gives you something a little bit funny. You get negative 1/4 on the left equals a negative 4. And you'd say, well, that's not even possible. Negative 1/4 can't equal negative 4. So what this means is that this one equation has no solutions. So it failed and kind of blew up in our faces, and it produces no answers from this one equation. We still have to look at our other version. The other version isn't the same because it has a negative x on the right-hand side, so to move it, we'll actually add an x to both sides. So that actually will not run into the same issue because on the left now, I'll have an x plus an x, which is a 2x. We still have our minus 1/4 and still have our 4 on the other side. Now, if you're one of those people who is terrified of fractions, you can get rid of them here by multiplying everything through by a 4 on both sides. What that will do is turn my 2x times a 4 will give us an 8x. On the next piece, by multiplying by 4, it actually gets rid of the fraction. It will cancel out the 2 4s, leaving you with just the negative 1. And on the other side, you still have to multiply the other side by 4, which gives you 4 times 4, which is 16. Continuing along, you'd solve this by adding 1 to both sides of the equation. And that would get you an 8x equals 17. Next step we would do is divide both sides by 8, which gave us, that x equals 17/8. And that is a reduced fraction. We do not want to convert that into a mixed number. So we are done. So technically we did solve 2 equations, but we only got one answer because our other equation fizzled out and kind of blew up in our faces. So we got 17/8 as our one and only answer.